Hello. Excuse me for my problems with the technical capabilities of the GoToWebinar system. I just didn't realize I had to press yet one more button in order for you all to hear me. So starting again from the top. The Mixed Emotions platform. This is the webinar, the technical webinar for the Mixed Emotions Big Data Emotion Analysis platform. First of all, if you have questions along the way, there's a chat and a questions tab. You can put questions in there, and we will try to answer them as we go, or at the end we'll take questions and cover them in more detail. If you have a pressing question that you would like to ask, you can raise your hand. I'll try and keep track of I can see that in my dashboard here, and I'll try and keep track of anybody who raises their hand and respond, allow you to have the microphone and respond as you ask. All right, let's get into it. So first, an overview. What are we talking about today? I'll briefly describe the Mixed Emotions project, what it is and who's doing it. I will talk a little bit about emotions and why it's useful and important to measure them. Then I will spend quite a bit of time going over the Mixed Emotions toolbox itself. This is a collection of various analysis tools for essential, primarily emotion detection, but many other things such as linked data related or semantic technologies. Then towards the end we'll see the platform in action. I'll present one of the implementations that we've made as a pilot project and as part of the Mixed Emotions project. So what is Mixed Emotions? It's a H2020 project. You'll see the emblem down the bottom. This is a European Union initiative. It's an innovation action. That means that its primary focus is to take state-of-the-art technology and make it available to small to medium businesses in Europe or indeed across the world. One of our directives is to make an open source big data platform, which is what I'm presenting today. So the primary focus is emotion detection across mixed modalities, audio, video, and text, and across languages as well. We can work with many languages. Integrated with semantic technologies. This is about identifying entities and being able to provide semantic context to your data analysis. Then we are creating, as I said, an open source big data platform. So this is for everyone to use and hopefully to improve as well. So why are emotions interesting to measure? What is so cool about it, and why is the European Union spending all this money on this project? So you can imagine kind of visionary applications of ubiquitous monitoring of emotions. Like there's a few examples here. You have a TV that knows you've had a hard day and gives you something that will kind of cheer you up when you get home. Or you can have a car that knows that you're in a hurry and you're angry and you're agitated, and it will give you warnings or try to mitigate accidents that could be caused by your emotional state. Or, for example, you're about to write an email that you're just writing in anger. It's a quick response and that you might regret later. And your computer might actually say, are you sure you want to send that? Don't you want to think a little bit more? These are the sorts of examples that ubiquitous monitoring emotions can enable. But there's also, for business, it enables a business to understand their customers. And that's really important as well. So the Mixed Emotions platform, this is like a very high-level overview of what the platform is. At the bottom there, we have the different types of content and data that are ingested by the platform. We have text from multiple languages and audio, images and video. We poll social media or various social media sources. Then we have a layer of the analysis technologies for detecting emotions and semantic entities and a number of other different things from different modalities. Then the next layer is the integration with the semantic technologies. This enables the contextual analysis. It enables you to do essentially semantic searches on the data to filter your data by by intelligent semantic queries. And then the top layer there is, for this project, we have 3 pilot projects. One which is making a social TV application for recommending news content based on the emotional, or taking into account the emotional responses to different topics in social media, for a call center to help manage the call center by monitoring the emotions in recorded calls at the call center. Then it helps the managers to understand what topics are important to the customers and that sort of thing. And the third one there is brand reputation management. We'll see an example of that later in the webinar. And, well, it's what it says. So for brands to try and understand what people are thinking about them, what they're feeling about them, the emotions of them. So MixedEmotions project has many contributors. There are 9 partners in all. We have 4 academic and 5 industry partners, and these 3 pilot projects that I mentioned before. So it's quite a large project. So the platform is built on a microservices philosophy. The idea here is, instead of having like a monolithic application where if you want to replicate it, you have to replicate this whole monolith on different computers, instead we divide the application into smaller pieces, each of which can be deployed by itself, and it makes for much more efficient use of resources. The main technology we're using for this is Docker. This is a recent kind of, I guess, an industry standard for replication. A Docker image is basically a virtual machine, or kind of a minimal virtual machine, or a virtual computer. And it has advantages over the, I guess, more traditional virtual machines in that they're smaller and use less resources. So they're very resource efficient. They usually communicate by HTTP interfaces over, which means that the orchestrator, which we see at the top here, that's a part of our platform and which manages the data flows. The orchestrator, once it knows the URL for a particular Docker image, then that's all it needs. That means that it can actually equally use URLs from static services or any service that you like. So it's very easy to integrate existing services into this architecture. Now, for the deployment, what we have been using, there are other options. Once you have a bunch of Docker, these Docker images, and you can deploy them somewhere, you can deploy them however you like. But the standard, again, this is the industry standard for deploying Docker images across some cluster. And for dynamic scalability, then the technologies of Mesos and Marathon are what we are using. Mesos is a resource manager. It supports running Docker containers. It also supports running Spark processes. If you happen to have Spark infrastructure, then you can run it over Mesos as well and integrate that into our big data platform. Marathon is basically a deployment tool over Mesos. It is easy using Marathon to scale up services to whatever size you need, or however many instances you need. And it also manages downloading and retrieving Docker images from Docker Hub, which is the repository we're using for the Docker images. Docker Hub is an open repository, and that's a part of what this platform is about. It's open source and freely available to the public. So we have a organization in Docker Hub where we have all of the images for MixedEmotions. At the moment, it's not complete. The project has a few months to go, and I guess creating the Docker images is essentially the last step for our programming, our development of these resources. So not all of them are yet in Docker Hub, but a good proportion are. And we also have an organization on GitHub where the source code for the Docker images is stored, and it's open source, so anybody can go in there and see the source code, copy it, and develop it themselves. One thing I should note here, in case you're wondering about the requirements for deploying these things, we have tested and done this in Linux environments. These tools that we're talking about are basically native to Linux. Now, you can run Docker in a Windows or a Mac environment, and one of the handouts that you'll be able to download from this webinar is actually a tutorial on how to run the orchestrator and a few Dockers and some other examples of MixedEmotions, excuse me, MixedEmotions modules on a standalone computer, even on your laptop. So that gives you some idea of the flexibility of this architecture, that you can run it on a very small scale, or you can scale it up to hundreds or thousands or millions even of nodes. Yes. So in order for these modules to be able to communicate effectively, in order for us to encapsulate the analysis in an effective way, we're using a standard for markup of the results. And this is based on JSON LD. That's JSON is the JavaScript object notation, and the LD stands for linked data. So linked data is about connecting, or semantically connecting different knowledge bases in order to be able to enrich, basically, the data that you have with existing knowledge in external knowledge bases. So we're using this linked data standard for our data representation. It incorporates other linked data standards wherever we can. We have standards for subjective opinions and emotions, and for natural language processing. That's NIF, MAL, and ONIX. Currently, the standard is primarily for text and social networks, but we're developing or making decisions essentially about which particular formats we're going to use for the audio and video markup as well. And they will be completed by the end of the project. To make it easy to create new modules of your own, or to integrate existing resources, analysis resources, into the system, we have Python and Java wrappers for which essentially encapsulate these standards and make it very easy to produce compliant software. So that makes it, the process of making your own modules is much simplified by that. Here's an example of the JSON LD format. Here we have, I'll bring my mouse over here. We have an analysis, so this tells us what the analysis is about. And then entries, these are the analysis entries. We have the original string here. You'll see the NIF here, that's another standard for annotating data, for linked data. So anybody complying, any tools that comply with these standards will understand that this is a string resource that is connected with this analysis. Then we have a section called emotions, and this is a list of the emotions that have been detected. You'll see here ONIX has emotion category liking. So this is a category from WordNet WNA, which is WordNet affect. And it has another one called excitement. So this piece of text has liking and excitement as the emotions that we've measured. This is what is output from one of the analysis modules, the emotion analysis modules from the MixedEmotions project. Now, the architecture is quite complicated, and I will introduce it part by part, piece by piece. We start off with the picture we've already seen here. There's an orchestrator. That is a program. It happens to be written in Java, Java 8 if you're interested. That basically manages the data flows. It manages the collection of data, storage of data, and then the passing the data between the modules, and essentially agglomerating the results of all those data analyses, and then storing the data in the storage technology we're using. Here at this, so we have Marathon and Mesos. We're going to be running Docker containers within Marathon and Mesos. This is inherently scalable, so if you have to do a lot of data, then and you have a lot of resources, physical resources, then you can scale easily. But we can also have non-distributed external modules. These are accessed by URLs, so the orchestrator is able to talk to them in an equivalent way to the Docker containers. But they're not scaled, so unless they have their own scalability underneath, somewhere that the orchestrator is not interested to know about, these are static resources. So first of all, where does the data come from? So we have modules for crawling Twitter and YouTube. Then the data which is collected by those is stored in some persistence technology. At the moment, it's the on-server disk that the orchestrator is running on, but it could be any technology that mimics that disk. Or perhaps at a later date, if we want to incorporate things like HDFS, then that may be possible, but someone would have to write the technology for that. At the moment, it's not a part of the orchestrator. But I think on-disk persistence for this task is quite sufficient for even quite large data analyses. And the user can also supply their own data sources. This is important because most, I guess, business applications, they will have their own data that they need to work with. One example is for the social TV pilot project. Deutsche Welle is the partner, and they have their archive of videos, which we have access, which is being accessed by the platform to make this social TV application. So we'll move on. The next step then, once we have some analyses, where do we store it? The storage that we're using is Elasticsearch. This is a good choice for several reasons. One, we'll see later that there's a visualization technology that we're using on top of it, which is very powerful. But it's also inherently scalable. It's designed to scale to multiple like physical storage resources, so that if you have a lot of results, then this is not an issue. Once you have Elasticsearch running properly, then you can scale up the results. One of the reasons why the persistence being on disk on the server is not such a big issue is that typically you don't need to store, it's like a queue for things that need to be analyzed. You don't need to store a lot of information before the analysis. It's after the analysis that you need it to be scalable, and that's where Elasticsearch comes in. Now I'll get on to the modules that we have for the analysis. First of all, the text analysis modules. We have sentiment extraction. That's nothing particularly new. It's quite an industry standard, but we have modules for sentiment extraction in several languages. We have text emotion recognition. Now that's a less established technology, but we have the state-of-the-art is implemented for emotion recognition from text. We have both dictionary-based and machine learning-based emotion recognition modules, and we have modules for different emotion representation schemes. The standards are, well, the two main choices are whether to have a categorical emotion representation scheme where you have a collection of maybe 6 basic emotions and you decide if any or which of those are present in a particular piece of text. And the other one is a dimensional emotion scheme where an emotion is represented as a point in 2 or 3D space or even 4-dimensional space. Again, these technologies are for different types of text also, primarily social media text, but we also have emotion and sentiment recognition for more generic text. The third one there, suggestion mining, is a somewhat more novel technology. This is something we're developing here in the National University of Galway in Ireland. Basically, it tries to recognize in a piece of text whether the author is suggesting something. So an example could be In a hotel review, the author might say that the 402 bus stop is just around the corner. So they're suggesting that someone who goes to the hotel and wants to catch the bus, it's telling them where the bus stop is. It's extra information, a suggestion. Another suggestion could be in a camera review, maybe it's not a very good camera, and someone says, don't use the automatic exposure meter of this camera. Perhaps they measured it and it didn't work or something. So it's not only a negative sentiment about the camera, but it's also a suggestion not to use that particular thing, or to use it, or, you know, there are many ways that forms of suggestions can come. And we've done quite a bit of research into trying to identify those, and we have a tool that is reasonably good at identifying suggestions in text. A second batch of text analysis technologies that we have in the platform are the semantic technologies. We have modules for topic extraction, again in several languages. This is, well, as it says, topics. It tries to capture the I guess topical nature of the texts, what it's talking about. The second one is entity extraction. That's about identifying particular entities. It may seem like a trivial task, but for example, if you think of, say, Barack Obama, how many different ways can Barack Obama be presented in a piece of text? It could be just Obama, it could be Barack Obama, it could be just Barack. It could be the president. There are many different forms in which a particular entity can be, by which it can be referred to. And there's a lot of work gone into trying to identify those different forms and identify the entities that are being referred to in text, and we have modules to do that. The third one there is entity linking. Once you've identified that a particular part of the text refers to some entity and you have some idea of what that entity is, then you can try and link that entity to existing knowledge bases. So a typical starting point would be what's called DBpedia, which is a knowledge base based around Wikipedia. But knowledge bases are more and more common in enterprise, where businesses collect their knowledge of their particular product, their particular domain, even their customers, and put it in a knowledge base, which enable these semantic queries, which are kind of much more meaningful than the typical or more traditional database querying technologies. Now, the last text technology which I'm going to refer to is machine translation. We have this as, well, no, I have it here as an external module, and the reason it's there is because it has really substantial, it requires substantial resources. The database for containing the information required for making the translations is quite large. Now, I just heard this morning from the author of this module that, in fact, he's created Docker images for these, for machine translation. They're quite large, a minimum of around 4 gigabytes. That's just for translation between one language and another. But they are now available as Docker images as well. Yeah, I should mention that that's our machine translation module. It covers translation between all of the official European languages and English and back again. So it really covers quite, I think there's 16 or so languages. Someone might want to correct me on that. Okay. Now, the next module I want to introduce is the audio emotion recognition module. And this provides second-by-second emotion levels in recorded voice audio using a dimensional emotion representation scheme. This is often, for emotion detection in text, categorical representation schemes have been used more widely, although there has been some work with a dimensional scheme. But with audio, it's the other way around. The dimensional scheme is more the state of the art, with some work in categorical schemes. This module also provides several other characteristics of the speaker, such as age and gender and personality, using the big 5 personality traits. The next module I want to introduce is the video analysis module. Again, this is in here as an external module. It is open source, But again, it requires substantial not only memory and disk resources, but compute resources. So it doesn't make a lot of sense to make this into a Docker. And I'm not sure that we have plans to do that. In fact, if you want to do efficient video analysis, you get a lot of mileage out of using graphics cards to speed up the analysis. And that's something that Docker is not very good at. The video analysis, another thing that is unique about it amongst the other modules here is that it's asynchronous in its operation. All the other modules, you give them a request with some data, and they will return in a short time the analysis that they do on that text or on that data. The video analysis, you pass it, you either upload a video or you pass it a URL for a video, and then tell it to start doing the analysis, and it will return and say, okay, I've started, and you can go on and the orchestrator can move on to other things. And then the orchestrator polls the video module every, I don't know, 10 seconds, I don't know how long, you probably can set that up. And eventually, when the analysis is complete, you can then ask the module to give you the results of the analysis. And it can take quite a bit of time, especially if you're, if the hardware you're using is not very strong, and if the video is quite long. The characteristics that the video analysis module can return are of course, emotion based on facial features. It estimates age and gender, gaze direction, and head pose. And also, it provides fairly detailed information on facial landmarks and actions. There's 18 facial actions that it tries to recognize, things like frowning and smiling and the like. The last module, MixedEmotions module that I want to present to you here is the social network analysis module. It's implemented as a product called Scanner, an open source product developed by UPM in Madrid. This one again is a little bit unique in that the data it requires is network data. It's implemented to look at the Twitter social networks. There's good reasons for that. Twitter is a very widely used platform, especially in a business context. So it has its own crawler of the Twitter network APIs. Basically, you provided a list of users, and then it conducts its analyses. Now, it calculates a whole array of, I guess, standard social network metrics for Twitter users. The results, they can be fed by the orchestrator into Elasticsearch, like all of the other modules. If you have a lot of users, this may be somewhat inefficient, and you can instead take the same results, which the module stores in an OrientDB database. OrientDB is a graph database, and this module uses its own database for the efficient graph analysis capabilities that the database provides. So you can take the results stored in the database and dump them straight into Elasticsearch to I guess, streamline this data storage process and make them available for later analysis in conjunction with the other results that you have from other modules. Now, this is the last modules that I want to mention, and I talked about this before, but there's scope for relatively easily producing your own modules, as long as you comply with this JSON LD standard. And they could be Dockerized so that they are scalable and managed by Marathon and Mesos, for example. Excuse me. I'm just getting over a cold, so I might be coughing a little bit, and I might become a little bit croaky as well. The user can also supply static API. So if you have some analysis which is already implemented and you have your own servers and everything set up, you just need to provide a small shim in order to translate the output into the correct format, to this JSON LD format. Then you can easily provide your own static analysis modules as well. Again, I should mention that we have Python and Java wrappers that make this process easy. Okay, now we're getting in towards visualization. The first thing here, once we have entity extraction and linking, but if we want to use, I guess, wider knowledge graph, or rather, in order to leverage the identified and linked entities, then we need to be able to connect the knowledge graph itself that contains those entities to the data collection for visualization. And that's what these modules are about. So you start on the left there, there's a cloud with some knowledge graph technology, or some, it's a knowledge graph is a particular type of semantic database, I suppose. Like DBpedia or Wikidata are examples, but there's also user knowledge graphs can be there. Then we have technology for taking those and putting the relevant parts of that into the Elasticsearch in order to use them in the visualization in a seamless and quite powerful, I must say, way. The last part then of the platform is the visualization. You can use any visualization you like, but we are using a product called Kibi, which essentially is an Elasticsearch extension and enables very rich visual analyses of data stored in Elasticsearch. It's able to perform Sparkle queries to leverage the information from the knowledge graph and the entity linking, and to basically slice and dice your data in whichever way you feel to give you some informative representation of the results of the analyses. So now, this is the platform. Okay, now I'm going to show you the an example of this platform in action. It's using a subset of the modules and using Kibi for visualization. So this is for the brand reputation management pilot project. There are two flows here, one that analyzes Twitter data, and another one you'll see in a second that analyzes YouTube data. So this is the Twitter analysis flow. The orchestrator is what basically manages the movement of data from place to place. The data is first collected from the Twitter streaming API by the crawler. It is stored on disk. Then the orchestrator passes the data tweet by tweet, and this is done in a parallel way. If there are multiple instances of the sentiment extraction deployed, then you can have tweets processed in parallel on those instances. Then so the tweets, a collection of tweets one by one, are passed to sentiment extraction, then to emotion recognition, topic extraction, and as we go, the JSON LD that encapsulates this piece of data, this tweet, it grows and grows as different analysis results are added to the JSON. And so at this point here, halfway through the analysis, we have the tweet, but we also have sentiment, emotion, and topics that have been identified in the tweet, added to the JSON representation. And then it goes through entity extraction and linking, and then the final piece of the final information, which is then stored by the orchestrator in Elasticsearch, is a tweet with all of these things, the sentiment, emotion, topics, and the linked entities. And they're all stored in Elasticsearch, which can then be visualized on Kibi. The video analysis is very similar. It does audio emotion recognition. It has speech to text. At the moment, we do not have a module in MixedEmotions for speech to text. But this pilot project is using an external resource to do that, and it's integrated into the flow of data. We then have very similar things to the tree: the entity extraction, emotion recognition, sentiment, and entity linking. Then all of this information is again stored in Elasticsearch. So here you can see the a snapshot of the marathon dashboard for this implementation. And you see the modules there. We have the audio emotion module, entity linking, entity detection, topic detection. At the moment, the text, sentiment, and emotion are not here. This is because that particular module is not yet in the Docker Hub. It will be. It's just a matter of us putting it there. But you know, there are many things to do at the end of the project, and that at this point in time is not present. So they're being accessed as an external resource in actual fact. But we see here that these have been deployed. They have a certain amount of memory, CPUs, etc. This is a snapshot of the Mesos dashboard, which is the technology that actually manages the resources. And we see here, for example, that the first three are entity linking. So there are 3 instances of entity linking running, which means we can analyze 3 pieces of text at the same time. This is a fairly small scale deployment, but you can easily imagine that if you have a much larger cluster, then you can have 100 or 1,000 instances running in parallel, and that it wouldn't be a problem that this technology can handle that scaling like that. Now, this is a snapshot of the Kibi interface. I'm going to try and take you to a live interface. It was working just before, so it should be working now. This Kibi interface is a data analysis interface that queries Elasticsearch. Now, you can see here, this is the results from the video flow that I showed you before. First, here on the right, we have arousal and valence measured in downloaded videos. This will be agglomerated across the YouTube videos that have been identified as relating to these 3 telephone products, Huawei, or telephone companies, Huawei, Samsung, and Motorola. And you can see the variation over time, that here's a peak in valence, which means that people are feeling happier about Huawei on this day. You don't see many troughs here. There's, for example, a slight downturn. Here's a downturn for arousal and valence. This is a characteristic of emotion recognition, that arousal and valence tend to be correlated. Arousal is about excitement, the level of energy, emotional energy, and valence is about positivity. Further down, here we see a categorical representation. This is a fairly typical categorical representation attributed to Ekman. It was used in a famous movie recently, whose name I can't remember right at the moment, but there are 6 basic emotions: joy, fear, anger, sadness, disgust. There's another one. Here we have neutral, which wasn't one of the basic emotions. Anyway, you can see the overall proportions here of the different emotions for each of the 3 telephone companies. And yeah, there's further down here we have the emotions associated with those companies, but other entities that have been. No, this is by YouTube channel. Excuse me. So these are the emotions associated with the different YouTube channels. Now, Kibi is very powerful. All of these graphs and tables are entirely flexible. Basically, you can put any collection or combination of characteristics that you like and plot them and graph them in these ways. So Kibi is what we recommend as a good visualization technology for the results of the platform. Okay, I think that's enough for that. We're now winding up the webinar. There are 3 handouts that I'd like to mention. First, the slides that I've been showing you are there as a handout. There's a page of useful links that has links to a few demos, online demos of some of the components of MixedEmotions, and contacts, ways in which you can contact the MixedEmotions project. And then there's one which is a tutorial for essentially running the platform on a single computer. The idea is to just give you some idea of its capabilities and how to use it, the orchestrator, for example. A recording of the webinar itself will be available. It'll be available on GoToAWebinar for 1 month, and we're also going to put it on YouTube, where it will say forever, presumably. All right. Well, thank you very much for being attentive and waiting with us. If you would like, we'll be very pleased if you could go and fill in a small form that we've created to get your impression of the platform and how useful you think it's going to be or could be. All right. Well, thank you very, very much. And are there any questions? So I have a question here. Are the individual modules interacting with each other? No, not directly. The orchestrator manages the interaction. So does anybody else have any questions? How do you cover the multilingual aspect? So some of the analysis technologies are inherently multilingual. Especially the voice analysis, the audio analysis, it actually performs reasonably well irrespective of the language, although you can get a better performance if you train it to specific languages. As far as I understand, we provide just a generic one which is trained on English and so works well in English-related languages. For the emotion and sentiment, we have modules trained in several languages, including Spanish, Italian, English, and Czech. We also have the machine translation capability. So you get a drop in performance trying to measure sentiment from translated texts, but you still get, I guess, a statistically significant measurement of the sentiment. One thing I forgot to mention, so Kibi, this visualization technology, it's actually a commercial technology where you can use it for free for a period of time, but it's an extension of an open source technology called Kibana. Now the difference between the two is that Kibi has the semantic extension, so it enables these sparkle queries, whereas Kibana only enables more traditional, I guess, things you would expect from a database query, which is still very powerful and extremely good, extremely useful. Someone says, okay, thank you. Well, thank you very much, Martin. Okay, well, if there are no more questions, I'll bring this webinar to a close. Thank you for attending, and enjoy the rest of your day. Thank you. Bye-bye.